All right, last section on factoring. So basically, this is just putting everything together. So if you see a polynomial and you're trying to figure out how to factor, this is one page of information that you can use as a strategy to do it all. So this is just basically putting everything we've talked about all together. So first thing you want to do every single time, if there is a common factor, you want to factor out the greatest common factor. That's going to be the best way to start factoring. Just always see, is there a greatest common factor? After you've done it, after you've taken that out, now let's determine how many terms there are. We have 2, 3, or 4 more. So if you have 2 terms, so this is going to be potentially one of our special forms, right? So that could be either the difference of 2 squares, the sum of 2 cubes, or the difference of 2 cubes. And all of that was in the video part 3. So if you want to refresh your mind on how to do that, that's all in part 3. So that's for 2 terms. If there are 3 terms, then we can factor it in the following, right? It's either should look like an x squared plus bx plus c, right? Or ax squared plus bx plus c. And if you need a refresher on that, the first one, that's all about part 1. The second one was in part 2. If it's 4 or more terms, right, specifically if it's 4 terms, try factor by grouping. The best way might just be factor by grouping. After you do all that, see if any of the factors that you've done with more than 1 degree, or sorry, more than 1 term, can be factored further. So this is definitely going to be anytime you have a square scenario, right? Anything bigger than a square, that might, plus something or minus something, more than 1 term. This is definitely going to be, can we factor further? And if so, you need to make sure to factor completely. So how do we know if we're done? That can be a way you ask yourself, right? If you keep going forever and ever, how do you know when you're finally done? If you have all linear terms, right? So it's x plus 5, 2x minus 7, right? Basically, every exponent is a 1, or you have monomials. So if you have all linear terms or monomials, right? So 3x, 7y squared. I mean, we can combine those two, but it'd be something like that, right? So you need, and then if it's anything other than that, you need to check to see if it's prime, or if you can factor out more. And then lastly, you can always check by just multiplying it all the way through. You don't have to check. Remember, there are some times in this class where checking is part of the equation. In this case, step 4 is optional. So that's just a good way to double check yourself if you have some extra time on a test or something. And this is it. This is how we do it. So we're just going to do 8 examples just to kind of put it all together, see what we got. If you notice on your handout, you should also have, I rewrote all of these steps, the differences, the squares, all these different ways of doing things. So this can be a good way to just kind of remind yourself how to do everything so you have it on one handout. That was at least the idea behind it. All right. So example number 1. So step 1, try to find a greatest common factor. Do we have a greatest common factor? Yeah, actually, we have a couple. So we can see that there's a 4, right? The numbers would be 4. And what would the variables be? X squared. So let's factor out that. So we got 4x squared. And what are we left with? So the 4 gets canceled. And we say if we take out 2 from the 4, we're left with 2. So x squared. The 2 is so in this time, right, the x squared is canceled. If we take a 4 out of the negative 16, we get negative 4. So, since we took out a greatest common factor, remember, it might be good just on the very bottom of your page to say, here's the answer. And just put 4x squared right out front so you don't forget. That's super important. You need to remember that. So now let's look at the 4x minus 4, or the x squared minus 4. So we have two terms. So is this going to be a difference of squares or a difference of cubes? Right, we don't have to check the sum because they're subtracting. Well, since it's a square, maybe it's a difference of squares. So what squared minus what squared? We see we have an x and a 2. So this is just x plus 2, x minus 2. All right, and then our final answer is all of it. Now notice we have a monomial and we have linear terms, so we're done. We don't gotta check nothing else. All right, next, example 2. So step 1, do we have a greatest common factor? Actually, yeah, we do. So none of the variables, but we can take out a 3 from all of this, which will make this problem so much simpler, right? If we take out that 3 first. So we take out a 3, what are we left with? X squared minus 2x minus, now we got to figure out what's 45 divided by 3. So 3 goes into 4 one time, multiply, subtract, bring down. 3 goes into 15 5 times, multiply, subtract. So we see that we get 15. So we took out a 3, so again, might be good just to, on the bottom of your paper or the bottom of the problem, right, end of the problem, just make sure you write a 3. There's a 3 there. We took out that. Good. So looking at the x squared minus 2x minus 15, right, this is going to be in this format. There's 3 terms, so we see that we can use our form for this. So we got to say what two numbers multiply gets us 15, or negative 15. So we have 1 and negative 15, negative 1 and 15. We have negative 3 and negative 5 and 3, 5 and negative 3, right? So we need to add these numbers up, and you don't have to do all of these, right? If you figured it out pretty quickly on, you can just write down what the numbers are. When we add them together, they should get us negative 2, right? So negative 1 plus negative 15 is negative 14, no go. Negative 1 plus 15 is positive 14, no go. Negative 5 plus 3 is negative 2. All right, so these are our numbers. So we know since it's a single x, it's x minus 5, x plus 3. And then our final answer needs to make sure to have that 3 out front. And if you wrote x plus 3 times x minus 5, that's fine too, right? We can interchange these all day long, not a problem. Good. All right. And since we have monomial and linear, right, we know we're done. All right, example 3. Do we have a greatest common factor? Yes, we do. What is it? Hopefully you saw it was 7x, right? And again, if you need to just, when we do these examples, just look at it, pause, and then fast forward to see if you get the same answer I do. I suggest that might be a really good practice, right? So if you're kind of struggling on these, that might be a perfect way to practice this. Just look at what the example is, try to figure it out on your own, see what my answer is, see if you see it, and if not, I walk through how to get all of it. So we get 7x, so we get x to the 4th minus 1. So we need to make sure 7x is included on our ending, right? So answer, make sure we have a 7x out front. So now we have x to the 4th minus 1. So these are 2 terms. So, and it's a difference. So is this going to be a difference of squares or a difference of cubes? Well, if we had something cubed, right, there's really no good number to get an x to where we would end up with a 4, right? Because we need these 2 numbers to multiply to get to 4, which that's just going to be gross, right? Fractions suck. So what if it was a square? Well, what times 2 gets you 2, or 4? It's 2, right? Yeah, x squared squared is just x to the 2 times 2, which is 4. So we know that we're going to do a difference of squares. And then, of course, that's just 1 squared. So we end up with x squared plus 1, x squared minus 1. And we're done, right? Aha! We are not done. Why are we not done? Because these are not linear. So we need to check both of these as well. So let's check x squared plus 1. So this isn't the sum. This is not the difference of, so there is no difference of squares, right? There's no sum of squares. And if you remember in an earlier video, I said if you have x squared plus some number, this automatically will be prime no matter what. So this one, we are all good. There's no such thing as sum of squares. So we can just include that in our answer because that is prime. We checked it, right? If you just want to double check just to make sure, we can say what two numbers multiply gets you 1. It's 1 and 1 and -1 and -1. And what do they have to add to get you? What are we adding? What's the number in front of the x? See, it's 0, so we need to get 0. If you have the two 1s, you get 2. If you have the two negative 1s, you get -2. Neither one of these is 0, right? So we see it's prime. However, we do have x squared minus 1. And that's the difference of sums again. So we just see that's x squared minus 1 squared. So we get x plus 1, x minus 1. Since those are linear, right? It's all to the first degree. We know that's probably it. So x plus 1, x minus 1, we're done. So this whole thing is the answer. All right. So example 4. Do we have a greatest common factor? We do not, right? This term doesn't have any x's. This term doesn't have any numbers. So that's as far as we can go. So nope. All right, we have 4 terms. So that means that we are probably going to do grouping, right? Factor by grouping. So x cubed minus 5x squared minus 4x plus 20. So when we group them up, remember, we have a negative, so we need to add that negative. Oh. Ooh. Well, sometimes that happens. Yeah, there we go. Computer just takes a little while to boot back up. Figure it out. Cool. So you need to make sure to add that negative. So for the first term, right, we get x squared, x minus 5. For the second term, we see -4 is in common, which would be x minus 5, right? In common with both of these, we see is x minus 5. And then what's left over? X squared minus 4. Are we done? Ooh, no, right? We got ourselves a square. However, this is as simplified as it goes, right? That's linear. So if you want on the very bottom answer, you do know x minus 5 is as simplified as it can go. So now he's got to check this x squared minus 4. So it's 2 terms. 2 terms tells us the difference of squares or difference of cubes. And since this is a square, it will be difference of squares. So what's being squared? You see it's x and 2. So we get x plus 2, x minus 2. And that's it. So our final answer will be x plus 5, or sorry, x minus 5, x plus 2, x minus 2. Cool, 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 cool. All right, halfway done. So 4 more examples. Example number 5. So can we factor anything? Is there a greatest common factor? Why, yes there is. What is the greatest common factor this time? We can see for the numbers, all of them are divisible by 2 because they're all even. For the letters, right, we got an x. So we can take out a 2x. And we're left with x squared minus 12x plus, what's 72 divided by 2? So that goes into 3 times, multiply, subtract, bring down. 2 goes into 12 6 times, multiply, subtract. So we got 36. Good. So remember, answer needs to include that 2x. So we can go down, right, for answer, 2x, so we don't forget about it. All right, so now we got x squared minus 12x plus 3. And since there's 3 terms, you can see that's the x squared plus bx plus c scenario. So what 2 numbers multiplied get you -6, adds get you -12? You may be able to see that it's just going to be -6 times -6, right? Because when you multiply those two together, you get +6. When you add them together, you get -12. So we get x minus 6 and x minus 6. So you can write it like that, right? And since these are linear, we're done, right? So we get x minus 6, x minus 6. You can also write them as 2x times x minus 6 squared, right? Because we're multiplying x minus 6 by itself 2 times. You can do either. Both of these are correct. So whichever way you want to do it, I'm fine. Number 6. Greatest common factor. Does one exist? Oh yeah, definitely. So you can see that we get a 3 and an x squared. So if you take 3x squared out, what are we left with? Okay, an x cubed plus an 8. Okay, so now we get 2 terms, and it's a sum, so it's the only sum we know how to do. Sum of cubes, which is good because we got cubes. So if you want to just write that beginning term out front, so that way you don't forget, make sure that's part of your answer. 3x squared. So now we just got to figure out, this is a monomial, that part's done. So then we got to figure this part out. So what cubed plus what cubed? You see it's an x and a 2, right? All right, so that's going to equal, so we do our, if we remember the formula, right? It's x, 2, x squared, 2x, 2 squared. And remember, the abbreviation is SOAP. Right? So same, opposite, always positive. So if we simplify that, x plus 2, x squared minus 2x plus 4. Now, we still got that one, but if you remember what I said last time, right? Anytime you have this, this is automatically prime. When you use the sum of differences, or the cubes, right? The sum or the difference of cubes, you always end up with a prime number or prime polynomial. So you don't have to check that. We actually are done. So we get x plus 2, x squared minus 2x plus 4 multiplied by that 3x squared. That's our final answer. All right, number 7. Like always, greatest common factor. Definitely. So we can see there's a 2 in common with both of the numbers. The x's aren't both places, but we do see that there's y's in both places. So if we take out a 2y, what are we left with? So 16x to the 4th minus y to the 4th. So we already got that 2y, so that's on that answer sheet, right? On the answer, make sure to put that 2y down. Then we get the 16x to the 4th, y to the 4th. So this is either going to be the difference, since it's 2 terms, right? Going back to our sheet, it's the difference of squares or cubes. Since it's 4, it's probably going to be squares, right? We already saw an example where that was squares. It makes things a little easier. So what squared minus what squared? So what squared is 16? That's easy, that's 4. What squared is x to the 4th? Hopefully you were seeing the pattern that we've been doing this over and over again. And we see that that's x squared. Same thing, what squared will get you y to the 4th? Well, that would be y squared. So we end up with 4x squared plus y squared, 4x squared minus y squared. Now, you do have to check these, right? Remember, I only said it wasn't for cubes, but this is squares, and so for squares, you do have to check. So, you don't have to check the positive. The positive is okay. There is no such thing as a sum of squares, right? So this is prime. The sum of squares doesn't exist. So we do have 4x squared plus y squared. That one's okay. But we should check this difference, right? Because we do have difference of squares. So something squared minus something squared. So what squared is 4x squared? Hopefully we can see that's 2x. What squared is y squared? Super easy, that's y. So we get 2x plus y, 2x minus y. And since these are linear, we're done. 2x plus y, 2x minus y. Good. Last problem, and then we are done with the factoring part for this section. Woo! Now, I'm just letting you know the reason why we're factoring is so important. There's a lot of people in my calculus class who doesn't know how to factor. So this is basic, and doing your best to understand it now will help you so much in the long run. So hopefully you actually have kept up with me up until this point, and so that you can hear all this stuff. So last problem, what do we do? Step 1, greatest common factor. So there's definitely going to be a greatest common factor in here. So out of the numbers, right, we can see definitely 4 is involved with all of them. Is there anything higher than that? Maybe not 4. Yeah. No, I lied. I guess 4 isn't. Yeah, 4 is not with 18. So 2 then. We can go down to 2. All of them definitely have a 2. All right. Not everything has a y, but everything does have an x, and the smallest of those x's is x. So we can take out a 2x. So we take out 2x, what are we left with? So we see it's 9x squared plus half of 4 is 2, half of 8 is 4, xy plus, we can see the 32 divided by 2, that's 16, so 16y squared. So once again, the monomial needs to come out front. We need to make sure to keep that in our answer. So 2x is a part of it. And then let's check out this one. All right, so we have 3 terms, and there's no way to simplify anymore because we already took out the greatest common factor. So we have that x squared, ax squared plus bx plus c scenario. So step 1, remember, let's multiply. So what's 16 times 9? 6 times 9 is 54, carry the 5. 5 times 9 is 9 plus 5 is 144. So step 2, what 2 numbers multiplied gets you 144, adds gets you 24. Sorry, gets you 24. And as you already know, I probably already said the answer because I did. You see both numbers are going to be 12, right? 12 times 12 is 144, 12 plus 12 is 24. So rewriting it, x squared, including the variables, so we get plus 12xy plus 12xy plus 16y squared. So we group them up. We don't have any negatives, so that makes things easy on us. So first term, we can take out a 3x. We're left with 3x plus 4y. Second term, we can take out a 4y. We're left with 3x plus 4y. I have these 2 terms. We both got a 3x plus 4y, and we are left with a 3x plus 4y. So again, you can leave it like that, or if you want to be fancy, you can square it, right? And since those are all linear, that is our final answer. Right? Or you can just write it once and say it's squared. Good. And that's it. So hopefully between all of these, factoring is simple and easy now. And as always, if you have any questions, just let me know.